Welcome to Math 105, Chapter 7.6, where we talk about Bayes' theorem. So we need to have a solid foundation with our previous lecture, Chapter 7.5 of conditional probability, and how to make your decision tree, like the diagram for a decision tree. That way we can kind of follow it around and see, okay, how do we get to these end products? And then how do we move forward with that? So in our example, we have your Bayes theorem, and we're just going to keep it very general for each problem. In our case, L and T, these are going to signify events. And so here for your Bayes theorem, we have this following equation. Now, as we're starting to build your decision tree, keep in mind with your decision tree, this is actually these two ideas right here are actually going to come up and be an and portion of your decision tree, the end result. So before we kind of talk about this any further, let's take a look at this first example and see if we can make sense of this. So it says, use L, a subject is lying due to theft, and T as the test is positive. So yes, lying has occurred, or so the test results come out to say. So somebody's perhaps taking a polygraph test, and this test is going to either catch the person or let them go, given that they might be lying or not lying, or in fact, perhaps there's some sort of false positive happening. So in which case, what is going to happen first? Are we going to be taking the test first, or is somebody going to be lying, being deceitful? Well, the first thing that we're going to do is perhaps have somebody lie. This is called your unconditional event, so whether you lie or you don't. Now, these cases here, this branch is the probability that this individual is lying, and the other counterpart is the opposite. The person is not lying. And then let's say they ended up getting caught, and so they're in the process of lying, and therefore they're going to be taking some sort of test. So this test that they're going to be taking, if it comes out positive, they have then been caught. Or if they don't get caught, it has come out negative. But no matter what, they're going to be taking this polygraph test. Again, you have T and not T. So when we look at this branch here, right, this is the conditional branch. Something has sparked you or sparked them to take this polygraph test. That is because they are perhaps stealing and therefore lying. So this person is taking the test, given that some sort of lie has occurred, some sort of deceit or theft has occurred. And the one under it is the probability that they fail or that they pass this test. So they got away with it, given that they're lying. And this next branch is the probability that they're taking the test, given that they're not lying. So it came out positive. This is like the worst case scenario. And the last result is that the test does not believe that they are lying. So it's testing negative, given that they are not lying. So that hurt. Everybody's being honest. So when we look at your end result, right, where you kind of trace your steps. So in this first result, right, somebody has been lying, and therefore the following probability was under the condition that, hey, this lying took place first. In which case the test caught them, right? It tested positive. So here we have that the person is lying and got caught. They tested positive for lying. So the test worked. And you might have to go to jail. Right? That's how it kind of works. This end result, this branch here, is the occurrence of these happening together. So you lied and got caught. You tested positive. Now let's see if we can do the same with the one underneath it. The probability that a person lied, and then under the condition that next, right, they were then tested on your polygraph test, and it's negative. So you got away with it. You lied. Lying has occurred, and you did not get caught. So you got very, very sneaky. You got away with it, essentially. Now, can you come up with the remaining? Well, this person is not lying, but the test believes that they are lying. So therefore, you're not lying, but you got caught anyways. You got tested positive for lying, or in this case, didn't even finish that thought, you tested negative. In this case, this is your false positive. This is the worst case scenario, right? Somebody is not believing in what you have to say. And again, I haven't done these portions. You lied and the test didn't catch you. You're not lying, but the test thinks that you are. And the last one, you're not lying and the test is testing negative. So they believe you. Not lying. And did not get caught. They are testing negative. So in this case, it all worked out. So when we come up with these probabilities in your following example, so when we kind of deep dive into it, right, we can kind of slowly trace our steps. Now at the end, right, notice that this portion here is the product between if somebody was lying, and here, if they were lying, therefore they got tested positive. They got, in fact, caught. That would be right here. Right? These two branches end up with these two simultaneous occurrences. So this portion here is just that the probability of somebody lied and then got caught. That is the two probabilities being multiplied together. That is right here. And we see that again down below. The probability that you lied and got tested positive. So you got caught, right? Those are the exact same. Now, this last branch here is somebody that did not, in fact, lie, but the test still believes that they are lying, that they are getting caught. That is your false positive here. Somebody is not lying, but the test believes you are. So therefore, this one is the probability that you're not lying and the test thinks you're lying. This is that false positive scenario, your worst case. Now, in the end, right, these are going to be the sum of your test results that it comes up as positive. That matches right here. Because what this is saying here is that we want to figure out the individual that they were in fact lying and they had stolen from the store. Therefore, we want to make sure that we are only summing up the total of the cases where we are testing positive. Test positive. In this case is all test positive, no matter your outcome. So you test positive given a lie. Or you lied given that you test positive. So now let's see your context. So it says, the Sherlock Lie Detector Company manufactures the latest in lie detectors, and the Count Your Pennies PYC store chain is eager to use them to screen its employees for theft. Now, Sherlock advises claims that tests miss a lie only once in every 100 instances. So 1 out of 100 instances. They are missing a lie, meaning that the test failed, right? The test itself failed. It did not catch you. Therefore, right, this is testing negative. Given that a lie has occurred, right? This is your false positive claim. You lied and you didn't get caught. That's why we missed the lie. Lied is what happened first and did not get caught. Sorry, not the false positive. I was just thinking a little bit too far ahead. I was reading something else instead of false positive, which is therefore our next counterpart. So it says, on the other hand, an analysis by a consumer group reveals that 20% of people who are telling the truth. So we know that they're telling the truth. So that has occurred. If they're telling the truth, they are not lying, but they failed the test anyways. So they lied, or they did not lie, but the computer, this test, thinks that they are lying. This is your false positive. So the computer thinks they're lying, or the test results think they're lying, even though they're not lying. That happens 20% of the time. That actually seems a lot higher, right? That's not what we want to see. Now, the local police department estimates that 1 out of every 200 employees, so 1 out of 200, has engaged in theft. Therefore, they lied about it. So we know that we have liars among us. So in our next part, I don't know why I have this right here, but when the CYP store first screens its employees, the test indicates that the Prudence V. Good was lying when she claimed that she had never stolen from the CYP, that company, right? So it thinks she's lying. So they have therefore caught her, right? They caught her, but she's saying that she is not lying. So what we want to know at the very end is that what is the probability that she is in fact lying? So we want to all figure out all of the test results, right? That accuse somebody that they are lying, right? Find all positive test results and compare them to those that are now lying. So we are trying to figure out the probability of L given T. So let's go ahead and look over here and try to fill in the gaps that we have and then figure out, okay, well, what do we not have? So we have the probability that somebody is lying. That is right here. So right here we have 0.005. Now, the opposite of a lie is somebody who's telling us the truth. So the complement of that is 1 minus 0.005, which gives us 0.995. Now, what else do we have? So we just took care of that one. We also have where somebody is lying, but the test showed a negative result. So they got away with it. We said that is right here. Therefore, this person, this probability is 0.01. And its complement, its opposite, is what? Well, this would be 0.99, right? Always the opposite. So far, this is what we've been given, right? We have this, and just by changing the opposite counterpart, we can find the other test results. Now, the last one is that they weren't lying, but the test believes that they are. So that would be right here. That would be this 20% here. This 20% or 0.2. Therefore, the opposite, 1 minus 0.2, is 0.8. So again, we don't have this one, but we have this one. Now, to figure out these probabilities here with your decision tree, that some conclusion has been found. That is, we're multiplying these outcomes, these probabilities to get to the end. So if we're trying to figure out, okay, they were lying, and then the test caught them, they tested positive, we get to multiply these two probabilities together. Or they were lying, and they got away with it. Or they were not lying, but the test came back positive for lying. Or they were not lying, and the test came back that, in fact, they were not lying. Therefore, at the very end, when we multiply these two, we should get 0.00495 and 0.12345, or 0.199, or 0.796. Now, what do we not have, right? I kind of filled it out, but we can do it here as well based on what we were missing in your decision tree, right? We said not lying. We said tested positive, even though we lied. We did not test positive because we're not lying. And we can do all of this by simple subtraction. And that is exactly what I did on my decision tree. And I'm just filling it out in my notes just in case I needed a reference earlier. Okay. So now if we want to find, right, kind of work our way backwards, given new information, where we want to tally up these values that you were tested positive. In our case, testing positive for a lie was anybody in this category at the very, very end, right here. So somebody who lied and got caught, that would be this part right here, and again right here. And somebody who wasn't lying, but still tested positive over here. So when it comes to your probability, we're just taking these results here, this one, and then again, one more time, this one. We don't care whether or not the person was lying, but we want to know, figuring out all of those who do test positive. So that's why this one is also necessary, because we're trying to figure out, well, what is that probability that perhaps they were still in fact lying or not lying in our case. 0.00495 divided by 0.00495 plus 0.199. Probability, no, T. Again, Bayes theorem is nice because you're kind of using your conditional probability, and then based on information that's coming out, maybe this person is claiming that, hey, I'm really not lying, right? Well, you then have to kind of update your findings. You're really not lying, right? You're perhaps telling the truth, or perhaps you're not, right? But you're, no matter what, you've tested positive. So you need to figure out, based on the new information, what is your new probability? And the forecasters, right? Think about meteorologists based on weather patterns, right? They take the historical weather pattern, but then based on your new information, they then have to keep an updated record of what they believe is going to come. And again, that will change with the new coming information. Now let's try it again one more time over here. And again, notice that your formula changes ever so slightly, and we're going to determine your formula here. Now it says it snows in Greenland on average of once every 25 days. So what do we believe? Let's say S is snow and G is going to be used for growing glaciers. So if we're just talking about snow here, let's just say, hey, the probability that it's going to be snowing is 1 in every 25 days. So about 4%. Now, when it does, when they're saying that, when it does snow, so snow is occurring, glaciers have a 20% chance of growing. So what is taking place right here, right now? Well, it's snowing, and therefore we want to know, okay, what are the chances that it's growing? That is going to be at 20%. Now, when it does not snow, so we know automatically when it's not snowing, that is occurring right here. Glaciers only have a 4% chance of growing. Now, what is the probability that it is snowing in Greenland when the glaciers are growing? So what is happening first? Well, the glaciers are growing, and we want to know, hey, what are the chances that it is in fact snowing? It's not quite just the reflection of this. No, it's not going to be 80%, right? That would be way too easy, right? Instead, we want to figure out, okay, well, what are the chances that right now the glaciers are growing? What are the off chance that it's happening to snow now? Like what is going to be now next happen, right? So when we look at your example or your formula, we want to figure out all of the times that it's growing to start, S and G. So all of the times that it is growing, it's either snowing when it's growing, or it's not snowing, but you're still growing. So that's why we have this growing here, even if it's snowing or versus not snowing. So again, you're going to have the same likelihood here, and then given some new information. And again, we said this right here is the chance of what? Well, it's got to be the chance of snow and growing happening together. The glaciers are growing, which again is here. Or perhaps here, we have the probability that it's not snowing and the glaciers are still growing. And again, kind of updating that information. So, can you build your decision tree? What is happening first? Well, in all of these, we're talking about perhaps it's snowing first, right? And then we'll kind of retrace our steps, being like, okay, well, we know that the glaciers are growing right now. Hey, what's the likelihood that it's going to snow, right? So that's kind of what's happening for our final result. Otherwise, we know that it's snowing versus it's not snowing, right? We know that snow is 0.04, right? That is here. And we do not have that it's not snowing. So 1 minus 0.04 is equal to 0.96. This is the chance that it's snowing. So the probability of snow, the probability of not snow. And therefore, our next decision, right, our next probability is whether or not our glaciers are growing or not growing. And again, these little probabilities, probability that it's growing right now, given that the snow is appearing, or the probability that it's not growing, even when it is snowing right now. Now, we were told that we have a 20% chance of this happening right here. So 20% chance that it grows right now as it's snowing. Therefore, its counterpart is when it's not growing, but it's still snowing. So 1 minus 0.20 is 0.8. Now, we also are given the probability that it's growing, but not snowing. We said that was 0.04, one more. So when it's not growing and not snowing, we have 0.96 once more. So we have 0.04, 0.96. There we go. So what are your end results? Well, if we're following your steps up, this case at the very end, it's snowing and growing. It's snowing and not growing at the very end. Copy, paste. One more time, this one is not snowing. But it's still growing. And the last one, neither are happening simultaneously. There you go. And again, these are the probabilities that they happen together, S and G. The probability of S and not G, the probability of not S and not G, and the probability of not S and not G. Oops, I already did that one on here. My bad. We'll just erase that part. Perfect. And keep in mind, what we end up doing is multiplying them together. So in the end, 0.04 times 0.20, 0.04 times 0.8, 0.96 times 0.4, oops, 04, 0.96 times 0.96. So in the end, we have 0.008, 0.032, 0.0, what is that? 384 and 0.9216. Perfect. Now, in the end, when we want to figure out your Bayes theorem, right? We want to know, okay, your glaciers are growing. So that would be right here. And then these other instances when your glacier is growing. So we have 0.008 over 0.008 plus 0.04. what was that? 384. We can put that into your Desmos. Oops, not the right one. So we have 0.008, 0.008 plus 0.0384. So there's a 17% chance of this actually happening. Versus, I think over here, I don't even think I finished it. I want to say it's about 2.4%. Let me see. My other one, I did not get to actually finish. Sometimes I kind of move on before finishing out our problems. I'm sure you've seen that on the previous videos. Like she is absolutely coconuts. 0.495 plus 0.199. Okay, so about 20 or 2.5 or so. Oops, 9. I missed a 9. Okay, so there we go. That looks better. Here we go. So hopefully Bayes' theorem, you're feeling a little bit more confident in the ways on how to put this all together. And notice that at the very top and the very bottom, this is when they're both positive and happening together. And then the addition portion comes from just your other segment. Okay, when else are we going to grow, or where else are we testing positive for your test results and so forth. Now, our very next video should be one that does this online as well with your Excel sheet. So make sure you watch our next video on how to do these exact ones just with Excel.